Have you ever wondered how inheritance and polymorphism work in object-oriented programming? Well, you've come to the right place. Object-oriented programming, or OOP, is a paradigm that uses objects, data structures consisting of data fields and methods together with their interactions, to design applications and computer programs. In the world of OOP, inheritance and polymorphism are two vital concepts that go hand in hand to enable the reuse of code, provide flexibility, and construct modular and extensible software. Inheritance is like the genetic code passed from a parent to a child, allowing for characteristics to be shared. Polymorphism, on the other hand, is the ability of these children, despite their shared inheritance, to develop and exhibit their unique traits. These concepts might sound complex, but they're the building blocks of efficient, effective programming. So buckle up and get ready for a deep dive into the world of inheritance and polymorphism. In this video, we will explore each concept and their relationship. So, what exactly is inheritance in object-oriented programming? Inheritance, in the simplest terms, is a mechanism in object-oriented programming that enables one class, the derived or subclass, to inherit the attributes and behaviors of another, the base or superclass. This is akin to how children inherit traits from their parents in the biological world. In the digital realm of programming, this concept facilitates code reuse and extensibility. How does it do that, you ask? Well, when a class inherits from another, it automatically gains access to all public and protected members of the base class. This means that all the hard work done in creating methods and properties in the base class doesn't have to be repeated in the derived class. Code reuse in action, but it doesn't stop there. Inheritance also provides the ability to add new features or override the existing ones in the derived class. This way, you can create a more specialized class that builds upon the functionality of the base class. That's extensibility for you. For example, consider a base class named Animal with attributes like name and age, and behaviors like eat and sleep. Now, you can create a derived class called Dog that inherits these attributes and behaviors from the Animal class. But as we know, dogs do more than just eat and sleep. They bark, wag their tails, and fetch sticks. So in the dog class, you can add these additional behaviors, creating a more specialized class. Just imagine the possibilities. From the animal class, you can branch out to dog, cat, bird, and so many more, each with their unique attributes and behaviors, all while reusing the common functionality from the animal class. As a result, you avoid redundant implementation and create a more organized and efficient code. So, to put it simply, inheritance allows you to avoid redundant implementation by inheriting common functionality from a base class, and it allows for the creation of specialized classes. Now let's move on to polymorphism. What does it mean in the context of OOP? Well, the term polymorphism hails from Greek roots poly, meaning many, and morpha, meaning form. So when we say polymorphism, we're talking about many forms. But what does that mean when we're in the realm of object-oriented programming? Quite simply, it refers to the ability of objects of different types to be treated as objects of a common type. Let's unpack that a bit. Imagine you're an artist with a box full of tools, pencils, brushes, markers, and so on. Each tool has a different function, but they're all used for the same purpose: to create art. In object-oriented programming, polymorphism operates on a similar principle. Objects of different types can be used to perform the same task, even though each object performs the task in a different way. Now, how do we achieve this polymorphism? It's generally done through function overriding and virtual functions. Function overriding lets a subclass provide a different implementation of a function that is already defined in its superclass. This means that the same function name can do different things depending on what object it's acting on. Virtual functions, on the other hand, are a bit of a game changer. They're functions declared in a base class that can be overridden in a derived class. However, a pointer or a reference to the base class can still be used to call the overridden function. This allows for dynamic binding, which we'll delve into more in the next scene. Now, what's the purpose of polymorphism? It provides flexibility by allowing a program to work with objects of different classes through a common interface, and it promotes modularity by encouraging the interchangeability of objects. This means that if you need to change one part of your program, you can do it without affecting the rest of your code. So, polymorphism allows a program to work with objects of different classes through a common interface, promoting the interchangeability of objects. We've discussed inheritance and polymorphism separately, but how do they work together? Let's dive into this. In object-oriented programming, inheritance and polymorphism often go hand in hand, working synergistically to enhance the functionality and flexibility of your code. One such way they interact is through dynamic or late binding. So what is dynamic binding? It's essentially the process that allows us to decide which method or function to use at runtime, rather than at compile time. It's like choosing which tool to use for a job, only when you're actually doing the job rather than beforehand. This is where the magic of polymorphism comes into play. Through function overriding and virtual functions, objects of different types can be treated as objects of a common type, allowing the appropriate method to be selected at runtime. Now you might be wondering, how does inheritance fit into this? Here's how. Polymorphism relies on a shared interface defined in the base class. When a derived class inherits from a base class, it also inherits this interface, enabling it to be treated uniformly with other objects of the base class. This shared interface is the bridge that connects inheritance and polymorphism. Imagine the base class as a blueprint. It outlines the basic structure and functionalities that all derived classes should have. These derived classes, while they follow the blueprint, can also add their own unique features and functionalities, thanks to inheritance. Meanwhile, polymorphism allows these uniquely featured derived classes to be treated as if they're the same type as the base class. This results in a system where we can write flexible code that works with objects of different classes, as if they're objects of a common class. In essence, inheritance provides the structure and polymorphism provides the flexibility. Together, they make our code more modular and extensible. This relationship between inheritance and polymorphism is a core aspect of object-oriented programming, enabling us to write cleaner, more efficient, and more maintainable code. So, there you have it. A brief overview of inheritance and polymorphism in object-oriented programming. Inheritance, as we've discussed, is a powerful tool for code reuse and extensibility, enabling us to build upon the functionality of existing classes. Polymorphism, on the other hand, brings flexibility and modularity to the table, allowing us to work with objects of different types through a shared interface. The magic really happens when these two concepts intertwine. The combination of inheritance and polymorphism enables dynamic binding, where the correct function implementation is selected at runtime. It's this harmonious interplay that contributes to the development of modular and extensible software systems in object-oriented programming. So, whether you're designing a simple app or a complex software system, these principles of inheritance and polymorphism can greatly enhance your programming prowess. Keep exploring these concepts and you'll soon see the power they bring to your programming. Thanks for watching.